Ever wonder how the world's largest renewable energy machines are actually built? We're talking about wind turbines so massive, their blades are longer than a Boeing 747. Get ready to witness the incredible engineering and colossal scale behind manufacturing these towering giants that are literally harvesting the wind. Take a look at this. Next to the Statue of Liberty, this modern wind turbine absolutely dwarfs it. Put one beside the Eiffel Tower, and it's still a titan. These aren't just for show. They are our future. We're in a global energy crisis. By 2026, the world will need a staggering amount of new power, and a huge chunk of that is expected to come from wind. The problem is, our older, smaller turbines just can't keep up. To meet the massive energy demands of tomorrow, we need to go big. Really big. This is the story of how we build those titans. It all starts with the blades, the most critical and visually stunning part of the turbine. These aren't just simple pieces of plastic. They are aerodynamic marvels, sculpted to capture every possible bit of wind energy. The process begins with a mold, a gigantic cavity shaped like the blade itself. These molds can be over 100 meters long, a testament to the scale we're dealing with. Inside this mold, layers of fiberglass and carbon fiber are meticulously placed by hand and by specialized machines. These materials are chosen for their incredible strength-to-weight ratio. They need to be strong enough to withstand hurricane-force winds, yet light enough to spin with the gentlest breeze. Once the layers are in place, a process called vacuum infusion begins. A massive plastic bag is sealed over the mold, and all the air is sucked out. This creates a perfect vacuum. Then, a liquid epoxy resin is injected. The vacuum pulls the resin into every single crevice of the fiber layers, ensuring there are no air bubbles or weak spots. It's a high-stakes operation. A single mistake here could compromise the entire blade. After the resin has fully saturated the fibers, the whole thing is heated or cured. This baking process solidifies the resin, bonding everything together into a single, monolithic structure of incredible strength. You're left with one half of the blade shell. They repeat this entire process for the other half, and then the two halves are bonded together around a central structural spar, creating the hollow yet immensely strong final blade. The precision required is insane. Even a tiny imperfection on the surface can disrupt the airflow and reduce the turbine's efficiency. Now that we have our colossal blades, what do we attach them to? That brings us to the heart of the turbine, the nacelle. Think of the nacelle as the brain and the engine room, all housed in a container the size of a small house, sitting hundreds of feet in the air. Inside this casing, you'll find the most complex components of the entire system. First, there's the main shaft and gearbox. The slow, powerful rotation of the blades, maybe just 10 to 15 revolutions per minute, is transferred through the main shaft into the gearbox. This gearbox is an engineering masterpiece. It's designed to increase the rotation speed by about 100 times, stepping it up to the high speeds the generator needs to operate efficiently. Imagine the forces at play here. This gearbox has to handle immense torque, day in and day out, for decades. Connected to the gearbox is the generator itself. This is where the magic of converting motion into electricity happens. As the high-speed shaft from the gearbox spins the generator, it creates a powerful magnetic field, inducing an electrical current. We're talking about generating millions of watts of power from a single turbine. Also inside the nacelle are cooling systems to prevent overheating, control systems that monitor wind speed and direction, and a yaw system. The yaw system is crucial. It is a set of motors that can rotate the entire nacelle to ensure the blades are always facing directly into the wind, maximizing energy capture. Assembling all these heavy, intricate components into the nacelle housing requires heavy-duty cranes and a highly skilled team. Each part, from giant gears to sensitive electronics, must be installed with millimeter precision. So we have the blades and the nacelle. How do we get them up so high? That's the job of the tower. Manufacturing the tower is a feat of steel fabrication. The towers are built in sections, typically cylindrical or conical, made from massive rolled steel plates. These plates are bent into shape and then welded together with automated, high-precision welding machines. The welds have to be perfect. They are what holds the entire weight of the nacelle and blades, while also resisting the constant force of the wind. Each section can weigh over 50 tons. Once a section is complete, it's coated with specialized paints to protect it from corrosion over its 20 to 30-year lifespan. Given that many of these turbines are located offshore, this protective layer is absolutely vital to combat the harsh, salty environment. These massive tower sections are then transported to the installation site, ready for the final assembly. This is where everything comes together in a truly spectacular display of modern construction. The journey from the factory to the wind farm is a logistical challenge of epic proportions. The blades, towers, and nacelles are so large they require specialized trucks, ships, and sometimes even custom-built roads. A single blade can require a convoy of escort vehicles just to navigate turns on a highway. Once on sites, some of the world's largest cranes are brought in. The construction process is like assembling a giant's toy set. The tower sections are lifted and stacked one by one, bolted together with hundreds of massive high-strength bolts. Then comes the heaviest lift, the nacelle. The crane carefully hoists the multi-hundred-ton house-sized box to the top of the tower, and it is painstakingly secured. The final, most breathtaking step is attaching the blades. The blades are typically assembled into the hub on the ground first, forming what's called the rotor. Then, in a moment of pure engineering grace, the entire rotor assembly, over 200 meters in diameter, is lifted into the sky. The crane operator, guided by a team on the ground, must perfectly align the rotor with the main shaft on the nacelle. The wind has to be calm for this operation, making it a nerve-wracking waiting game. Once aligned, it's bolted into place. The giant is complete. As the blades finally begin to turn, it's not just a machine starting up. It's a symbol of our commitment to a cleaner, more sustainable future, brought to life by incredible ingenuity and sheer scale. The impact of these giant turbines is transformative. A single large offshore wind turbine can power thousands of homes. A whole farm of them can power an entire city. By harnessing the relentless power of the wind, we are drastically cutting our carbon emissions and moving away from fossil fuels. It's a key part of the solution to climate change. And the technology is only getting better. Engineers are already designing even larger and more efficient turbines, pushing the boundaries of what's possible. We're talking about blades that could stretch the length of 2 football fields. The future of energy is being written in the sky, powered by these magnificent wind-harvesting giants. What we've seen today is more than just manufacturing. It's a symphony of design, logistics, and construction on a scale that's hard to comprehend. From the delicate crafting of a blade jet to the raw power of lifting a nacelle into the clouds, every step is a testament to human innovation. These titans of tomorrow are not just machines. They are beacons of hope, silently and efficiently powering our world, one rotation at a time. The next time you see a wind turbine on the horizon, you'll know the incredible story of engineering and ambition that brought it there. Thanks for watching. If you were amazed by the scale of these energy giants, make sure to hit that like button and subscribe for more deep dives into the technology that's shaping our world. See you in the next one.